We're going to be taking a look at more advanced antiderivatives, and in order to solve a lot of these, we will be using something called U-Substitution. I use a little slogan when I teach this: it's up to you. So what does that mean? Well, that means you have to determine what your U is. I'm going to help you figure that out as we go through each of these examples. First, we have there's this little slogan I like to use. How do you know when to use U-Substitution? Well, up to this point, we haven't had to do it. Basically, if you look at an antiderivative and you ask yourself, what in the world do I do here? I really can't use any of the rules I've learned before, like, for example, antiderivative of cosine and sine. If you can't figure it out with a simple rule, then you probably need to use U-Substitution. So without further ado, let's take a look at something where you'd have to use U-Substitution. Example 1, we have the antiderivative of 3 times 3x minus 1 to the 4th power. Another way of explaining when to use U-Substitution is when you have a function inside of a function. So it's kind of like the reverse of the chain rule. You'd have to use the chain rule to take the derivative of this, to take the antiderivatives even more complex. This expression would be an absolute pain to expand. In other words, we don't want to take 3x minus 1 and multiply it by itself 4 times. In this case, it's going to be a lot easier to use U-Substitution, which is what we're going to do. So again, you cannot use a simple antiderivative rule here. That's when you know you're going to use U-Substitution. Let's take a look at some steps to get the right answer here. Step 1, determine which expression is U. 9 times out of 10, it's going to be inside of another function. So like I said before, 3x minus 1 is being raised to the 4th power. So if you think about the derivative, you would use the chain rule here. You have to move the 4 down, and then it would become cubed and multiplied by the derivative of that is 3. But again, U-Substitution is kind of like the reverse of the chain rule. So since we have a function inside of another function, this is a linear function inside of basically a polynomial function. 9 times out of 10, that's going to be your U. So since 3x minus 1 is being raised to the 4th power, we're going to set U equal to 3x minus 1. Now, in a little bit, I'm going to explain why we have x equals U plus 1 over 3, but for now, all you need to know is that U is equal to 3x plus 1. All right, so why is U equal to that? Step 2, we're going to take the derivative of our U function. So U is equal to 3x minus 1. Notice that if we take the derivative in terms of x, on the left we're going to get du dx. On the right, the derivative of 1 is 0, so that won't matter. The derivative of 3x is 3. So we have du dx is equal to 3. So again, step 2 is just take the derivative of your U expression. In this case, U is equal to 3x minus 1. So we have du dx equals 3. We're going to use that as well when we go to take our antiderivative. Step 3, once you take the derivative, du dx equals 3, you want to get dx by itself. So notice that we have our dx is right here. In order to get dx by itself, we will have to multiply both sides of this equation by dx. Another way to think about it is cross multiplication. You'll get du times 1 is equal to 3dx. Or just du equals 3dx. Then divide both sides by 3, and now you will have dx is equal to du over 3. So this is step 3 is equally important. You want to get dx by itself. And right now you're probably thinking, how are we using all these steps? Like, how do all these apply? Well, just bear with me. Okay, you're going to see how we use each one of these. There's a reason why it's called U-Substitution, because we will be substituting things in the expression with U. There's a reason why we are taking the derivative, and that's because you have a dx in your expression. If you look here in the original question, there's a dx here. It needs to be replaced in terms of U because we're converting everything in terms of U. So now we have dx is equal to du over 3, and we're going to put all this together for step 4. Step 4, replace expression by U and the dx in terms of du. Notice how we just said that dx was equal to du over 3, we are going to be replacing dx with du over 3. Okay? And we also said that 3x minus 1 was equal to u from step 1. So we're going to be replacing 3x minus 1 with u. So now we have the integral of 3u to the 4th times du over 3. And you can already see that these 3's are going to cancel each other out. It's going to lead us to step 5, which is to simplify. So when we cancel these 3's out, we just left with u to the 4th du. Now you can see why we did everything we did, because we can take the antiderivative of u to the 4th very simply using the reverse of the power rule, whereas before we had all of this stuff, we could not explicitly take the antiderivative. So, it's important not only that you figure out u, but you figure out what dx is in terms of u. And again, we did that. We figured out it was du over 3. So now we just have the antiderivative of u to the 4th du. That leads us to step 6. Sometimes, not for this example, but sometimes you will replace any remaining x's in your expression in terms of u. So let's say we did all that and we had like antiderivative of u to the 4th times x du. You cannot have an x in there. And that's what I was doing before here. Let's say that did happen. You can easily get x by itself in this expression by adding 1 and then dividing by 3. And that remaining x you would replace with u plus 1 over 3. But because we're not doing that, I'm just going to erase all this stuff so you don't get confused. But that will happen. You do not want an x at all when trying to take the antiderivative. You want everything in terms of u. Okay, and so we've achieved that for step 5. Everything is in terms of u to the 4th du, so we do not have to do step 6, but you would if you did have an x. Step 7, ensure that the remaining expression is antidifferentiable. So not only does it have to be in terms of u, but you do have to be able to antidifferentiate it. If not, you have to do some simplification, and again, we'll look at an example like that. We can antidifferentiate u to the 4th. It's going to be the reverse power rule, so it's 1/5 u to the 5th plus c. It's going to be the antiderivative of u to the 4th. That is a terrible plus c, so I'm going to redraw that. I was using a different medium before. Okay, so for step 8, take the antiderivative. And, it should be really easy at this point to take the antiderivative of your u expression. That's why we do U-substitution, because it makes it easy. But now we have a 1/5 u to the 5th plus c. Our original problem was in terms of x. So we need to convert that back to x. Now fortunately we know that u is equal to 3x minus 1, so that will be easy to substitute back in. Again, hence the name of the lesson, U-substitution. We're going to be replacing this u with the 3x minus 1 that we had originally. And so that leads us to step 9, change u back in terms of x. So we'll replace that u with 3x minus 1. Again, that's to the 5th power, all plus c. Again, I'm not happy with the way that plus c came out, so I'll draw that real quick. All right. Now this is our answer. Okay, so the antiderivative of 3 times 3x minus 1 to the 4th dx is equal to 1/5 times 3x minus 1 to the 5th plus c. How can we check that after we've done step 9? Well, we can just take the derivative of that for step 10 to make sure that we get the original back, and we do indeed get 3 times 3x minus 1 to the 4th back when we take the derivative of our answer. So that's it for our first example of U-substitution. I tried to keep it simple, just because we want to start out simple and get a little bit more complicated as we move through. But that's the gist of U-substitution. Again, probably the most challenging thing at first is figuring out what your u is. But again, 9 times out of 10, it's going to be kind of like the inside function. Again, it's kind of the reverse of the chain rule. Also, another hint that I'm going to give you before I go on to the next example is, your derivative of whatever you make u equal to, your derivative should give you something that's already in the expression, in this case 3. So you kind of have to think ahead, because if the derivative of 3x minus 1 is 3, it's going to end up canceling this 3 that's already in there, and you want to cancel stuff out when you do U-substitution. So there's another hint for you as far as how to figure out what u is, but as we do more examples, you'll get more comfortable with figuring out what the correct u is going to be. Another thing I do want to say is, you can always choose the wrong u. Let's say you made u equal to 3 here. You're going to figure out real quick it ain't going to work. You're not going to be able to take the antiderivative because you won't be able to get it all in terms of u when you go and try to take the antiderivative. So sometimes it's trial and error. If you have any other questions about example 1 of U-substitution, let me know.